Good evening, everyone. My name is Lucas Fricky.
And I'm Autumn Lemmer. We just want to thank you guys all for coming out tonight to our Engler lecture. Every semester we invite a professional to come talk to us at the Engler lecture. We just talk to successful entrepreneurs so that they can share their story and we can learn and grow from them. Be sure to use this night as a networking experience because we have the privilege to welcome one of the most inspiring individuals in agriculture today, John Eastin of Kamterter.
John received his undergraduate degree from the University of Nebraska in technical agriculture. He'd followed that by receiving both a master's and doctorate in crop physiology and ecology with biochemistry and statistics minors from Purdue University. John was ahead of his time in working with plant biochemistry. His passion for learning and exploration helped him to advance himself through the university system and into private industry. Having a brief stint as a Wisconsin agronomy professor, director of DeKalb Physiology and Genetics, independent product development, and farmer crop physiology genetics consultant, that all wound up together and became the founder and president of Kamterter Products, LLC, and adjunct professor of practice at UNL.
It's amazing what one can do with an idea, fire in their belly, and a goal to fix a problem. Entrepreneurship is not a recipe. It's a combination of what each and every one of us can bring to the table. It's a story that shows what each and every one of us can do. This story of others helps us to persevere when the going gets tough and the competitors get fierce.
It is our pleasure to help kick off the 2014-2015 Engler Lecture with Nebraska's own John Eastin.
Well, it's a real pleasure for me to be here this evening, and it was a big pleasure to have a chance to visit with the young ladies and men that came with all those loaded questions this afternoon, and we had a lot of fun exploring what the nature of their problems were, as well as dreaming about some of the possibilities on solving the problems. And I'm going to, the company, Kamterter Products, is the company that I am now involved in. Founded the company in 1981. We'll go back and look at the history of how we got there. But our mission, as you can find this, really focused on delivering proprietary enhancements and delivery systems for crop production inputs. And we're focused there because we don't want to try and compete with the big guys. We want to make their stuff better. And so that's the base, the background for the company. Let's see if I can, So our approach today is, well, first of all, Tom, when he talked me into doing this, said, I want you to do a story on the good, the bad, and the ugly. And there'd been some of all of those. And I would start off by saying that one of the neat things is going through those good and bad and some ugly things. A real important thing in my life was that lady that said, for better or for worse. It's being big. And so anyway, I'll start the personal history, background, perspective of where I come from. We'll talk about the history of the product development activities, and then we'll muse a little about product and business development factors involved that I think are involved in being successful, that are based on my experience. And start off the personal journey. Farm kid from Madrid, Nebraska, that was lucky enough to have a job early in life away from the farm, as well as back on the farm during school, so you could still do milk the cows and do the chores. And in 1958, I received my technical agriculture BS from the University of Nebraska. And in the middle of that, one of the experiences I've had that's influenced me in looking at how the world operates was being in the military, Korea and Japan during the middle of that degree thing. And it might be of interest to you folks to know that when I went to the University of Nebraska the first 2 years, my scholarship was $250 a semester, and that paid for all of my books and tuition. So that was a year or two ago, though. At Purdue, I got my MS in crop physiology and ecology. I was very lucky, placed in had teaching experience. That was a nice thing for me, real learning experience. I had a major professor who was a crop physiology and ecology teacher, and so he had no research program. That left me high and dry as far as trying to figure out what kind of research project I would do. And so in retrospect, I thought I was pretty abused then, but in retrospect, that was a pretty good experience to have to go out and dig and say, what kind of a problem do I want to try and solve in doing my research program? And so I was very fortunate in that, and actually made it through as well. 1963, finished up my PhD in crop physiology and ecology, biochem and statistics minors. And again, I had the same major professor because I liked him, and he was willing to put up with me. And so we ended up, I had to apply for a research fellowship. I had to write a proposal to get a grant to support my stipend and to do a research program, and then hunt around for a professor that would take me on. And so I was very lucky in the experiences that I had in having to look at, okay, what kind of a problem is out there that I want to try and tackle to solve. I didn't know it at the time, but it was a good experience. And I see what I really was impressed with today is the way the kids I got to talk to, no, the young men and women that I got to talk to, and how they're working at defining problems and looking at solutions. And so it was really encouraging. It was fun. So after 1963, you can see I took a job in 1962. In the summer of '62, I didn't have my degree yet because these were in the days when the computer that you process data on was about the size of this section over, lots of vacuum tubes. And they installed a new 1360, took out the old 1060, and it wouldn't process my data. And so, but those were also the days when you didn't do figures on computers, you did them with Indian ink drawings. And those nasty professors, if you made a little nick in them, you did them over. And so the technology today as related to what we were then is just, it's unbelievable. And so anyway, I ended up taking the job at the agronomy faculty, University of Wisconsin. And one of the things that happened to me that was an everlasting memory, I was really lucky, is when I arrived at Purdue, they had a new facility. The Lilly Hall of Life Science was just been built, and they were dedicating it. And here's this farm kid from Nebraska, and they're going to dedicate this thing, and well, who are the people that are coming for the dedication? Well, it happened to be Watson and Crick, who are the people that elucidated the structure of DNA. And one of the luckiest things in my whole education was I had to take a microbiology laboratory that first semester. They were there as sabbatical people, and they were working in the lab where we had our microbiology lab. And so, gee, once a week you were in there with Watson and Crick. And we were actually enslaved in the process of doing the enzyme analysis to see that the genes that they were inserting in a bacterium using the phage techniques were functioning. And so I sat in there and boy, I'm just out of Nebraska. I was thinking, oh my, they're taking a gene from one organism and putting it in another one. And it works. And so that was a big influence on me. I've never forgotten that. And listen to those guys. Crick was great. Watson was kind of full of himself. But anyway, in 1962, I took my job at the University of Wisconsin. I was told that I was to develop a new course on the application of basic science to crop improvement. And boy, when they told me that, wow, you got all this freedom to do that. And I was told that I could do research on whatever I wanted to do as long as it had to do with crop improvement. And this was just, man, you had all this freedom, and I was there for a while and trying to figure out what to do and what to teach, and then all of a sudden I realized that, it was a course for graduate students that had just finished all of their PhD group work and from the various departments on the campus. And so, man, what am I going to teach them? They're all more current in their coursework than I was. And so we decided to deal with problem solving. And so the class, I learned so much from it, and it was such a marvelous experience for me, both going there for the teaching and the graduate research, to say, what are the problems, how do you define them, and how do you approach them? Because that's what you guys have to do also in your entrepreneurial activities, isn't it? You got to define the nature of the problem. Part of the problem is the product, part of the problem is the market, part of the problem is the manufacturing. You got a whole host of things. And in today's information world, it's even more complex than it was in those days. So anyway, I had a great experience at Purdue and problem solving, again, at the University of Wisconsin. And at Wisconsin, I was fortunate enough, because of some of the research I was doing, to have two people. One of them, we have a building named on the campus, the Beetle Center. George Beetle, the Nobel Prize winner for the one enzyme, one gene hypothesis. And Barbara McClintock, the Nobel Prize winner for her jumping genes work. And they both happened to be doing sabbaticals at the University of Wisconsin when I was there. And I was working with some germplasm in my work on physiological reproduction, source-sink relationships. And they both had experience with some of the gene constructs we were trying to work with. And so it was really fun. And you learn to really ask questions. You learn so much by having a dialogue with people like that. You don't want to be afraid to not know. You got to have a dialogue, and those were experiences that I'm a pretty lucky guy, And so then in 1968, I was asked to deliver because of the work I was doing in corn. They were dedicating the CIMMYT, the International Maize Research Center in Mexico City, the CIMMYT group. And for some reason or other, I was asked to give a paper on some of the work I was doing. And when I got there and had a lot of fun giving the paper, and Pat went along, and those two were got to visit Grandma. And we got there and found out that, well, I was interviewing for a job too, and it made me start thinking about it. And DeKalb had been after me to come and set up a physiological genetics program, and we didn't think those two would be very good in a private school in Mexico City, and so I got serious about the job at DeKalb, and it was to set up a physiological genetics program at DeKalb, and it was the first one in the industry. And again, I thought that was a great opportunity until I got into it and figured out how hard it was. But so anyway, I had a lot of experience that I didn't know was preparing me to be a wild-eyed entrepreneur, and how to think and solve problems. And so at DeKalb, you know, an example of the way that when I went there to interview, Tom Roberts, the CEO, family owner of the company, I asked him, you know, what kind of a budget do I have to set up this whole brand new program? And we were having lunch, and he looked at me and said, "Why would you ask me? You're the one that's going to be in charge." And I thought, "Ooh, this is a different thing than the budget I worked at the university." And so anyway, I took the job and was there for 5 years, and then Pat reminded me that it was age 38 when I left, and decided for better or for worse to go off on my own. We came back to Nebraska at a farm, and I worked as a consultant, and was a crazy inventor. And in the process of doing those first few years, I was working on a fertilizer reactor that would take ammonia, feed it into a center pivot, and turn it into ammonium nitrate. It made NOx or NO2 and converted it, and I had it work, and I got a patent on it, and that was one of the ugly ones. I never spent a lot of money, never commercialized it, because I didn't understand at that point in time that you do not sell technology, especially if you don't understand the structure of the industry and how it would work in it. And so that was an ugly one. Spent a lot of money, really was embarrassed as well as broke. And so that's kind of the history on some of the history on what we went through to get prepared to not know any better than to go off and leave a good job and come back. And so that's gotten us into I was at this point in time as I was crying and worrying about what I was going to do, farming and doing consulting work, and I was supposed to know something about seed physiology and genetics. And so Ciba had hired, or they'd bought Funk Seeds, and they had brought Mary Dell Chilton on board, the person who invented the, out of Washington University at St. Louis, that had invented the agrobacterium gene transfer systems. And so they were trying to decide what they could do. This is a new deal. I've got a seed company. Now I'm in seeds. I'm not just in chemicals. And they had a microbiology program. And so they were willing to pay money to have me come and help them strategize. And so we look at the things. I was supposed to know something about seeds and ecology. And so you look at it. And it's pretty simple in defining what you need to do if you're going to try and make a microorganism grow on a surface. You know, they grow where it's damp, don't they? They grow on a hydrated surface. It's pretty easy to understand that metabolic activity takes place in a tissue that's not a bag of water. it's a hydrated surface, isn't it? And if all you guys are farmers, you understand terrestrial ecosystems, soils. So the ecology of, and if I want to put a chemical on something, it goes on a hydrated surface, doesn't it, to be taken up, to diffuse. And so it was pretty simple to draw them a triangle and put a chemical on one end, a microbe on one end, and a plant on the other, and say, look, you got genes on the chemical, on the microbe and the plant side, and you know that these chemicals have genetic specificity. For the microbe, you know that the plant microbe interaction is that way. So you got to look at this thing in that triangle. That's your holy trinity on looking at the strategies that you need to do in going forward in this area. And so we said, okay, we're going to deliver metabolically active hydrated seeds to the soil. They wanted me to run a project, and so I was fortunate enough to get some things done with it and deliver hydrated beneficial microorganisms growing on the seeds so that they'd be there, they'd colonizing the seeds, the target, when they went into the soil, and delivering nutrients and chemicals to seeds and microbes. And so we ended up with, this is a suspension of corn seeds that if I take that suspension of corn seeds and I put them in a tube that I can put a shear plate and auger in here and run them out to the tip, and now I can take air and pull that seed off and tip it into a row. And so I was looking at how uniform these were coming off of here, and look at that spray here. That's a 12,000 centipoise fluid. That's thick, gooey stuff, about like tapioca pudding. And it would spray with less than 1 psi air coming off of there, because what's happened, I skipped a few, didn't I? Yeah. That's what happens when you get older. Phase arthritis, all that kind of stuff. But you see, if you want to look at this, you see what you've got here is you've got a shear surface. And so what I'm dealing with is a fluid here and in a liquid, and I'm dealing with fluid here and air. So all I'm doing here is transferring kinetic energy from the air to the liquid, and that makes me form drops. And the shape of the surface and the shape of the airstream is the shape of the pattern. So all of a sudden we're looking at this, and I'm saying, oh my golly, and see if I stop this. This is kind of like putting your finger over the straw. It won't drip. The liquid doesn't flow. You know, you put your finger over the straw, it doesn't drip, does it? So you stop the motive force on the liquid, or if you tie that motive force to the ground speed, you speed up or slow down. See, it's in direct proportion. And so you deliver materials in a very discrete way. So I'll get on to that later, but I wanted to get into the basis for that, what you're going to see later on spraying systems. So anyway, because what happened when we dump those things in a fluid, that's, you know, if you're a farmer and you get a toad strangler out in the early in the spring and it's cold, you don't get a very good stand, do you? You have anaerobic conditions for the seeds, and they will, the weak ones will die. So anyway, what we put corn, we had half-life problems with the seeds, and because of the anaerobic conditions, we discussed Ciba. Well, we should do a seed priming project because that makes the seeds work better, And then again, they had me working on that, and they opted out a little over a year after that project because they had changes in executives who were running programs. And so I had an agreement with them, and again, this goes back to agreements, where if they did jump out of a project I was running, it was mine. And so anyway, we ended up with a patented solid matrix seed priming process. And that's the basis for our business today. So the seed priming project focus was, that Ciba we had with them, is seed enhancement, doing beneficial microorganisms. We can grow them. We put the seeds in a material, a clay mineral that is tightly controlled as far as water potential, and so you can control the potential water potential in the seeds, the amount of in them, and then beneficial microorganisms will grow on the surfaces. So, the pesticide growth regulator, nutrient delivery systems, obviously you can put them in there because the hydrate and solid matrix was a key to dealing with something. All the things and technology before had been putting them in a salt solution. You all know that if you go out in the ocean, it holds water. You can make salt solutions that keep seeds from taking up water too, and our polymer solutions. And so, anyway, I looked at it and I said, boy, that's not very smart to use solutions. And I used to tell the graduate students, you want to solve a problem that has to do with biology and crop production. Mother Nature has provided you some examples for a long time, and you better look at how that's happening out in Mother Nature if you want to try and manipulate it. And if I want a seed to germinate nicely, I put it where there's good gas exchange in a moist soil. And so you had to be pretty dumb to not use solid matrix priming instead of solutions, and that's been a very good thing for us as a business, and much friendlier to operate. So this is what happens when you prime a seed. You can see here's the curve here for prime seeds, how uniform they come up and how much quicker. Here's what happens in a raw seed. And so you come up quicker, you come up more uniformly, so stand is very much improved. This is a diagram that shows what happens with a prime seed. We have a lot of vegetables that go to the, over September, they'll send them in to us, and because they want them primed, because they want to plant them for the winter crop in the south, and it's hot there. And so they have dormancies, many of them, that they won't germinate unless you treat them. And they also, in the spring, if you treat them right, they will germinate at 5 to 10 degrees cooler soil temperatures. And so the guys in the spring really want that treatment. And so our biggest customers in the area, this is a visual of what happens with a pepper seed. Which one would you rather plant? That's out of a production lot. Back to the corn fluid seed and singulation and spraying. We went through this, why we do. So like I said, we move a column to the surface, distribute it. Fixtures are designed so that you interact the two kinetic energy fluids. You can vary particle shapes and sizes in it. You can singulate them, or you can just spray a fluid. And fixture characteristics determine the pattern. The fluid column is positive displacement. And so these are just the principles that are involved in seed singulation. Back to a summary of what we're involved in as a company now. Product development tool chest. We have the solid matrix seed priming. We were able to work with the seed treatment, chemical, microbial, and physical. We do seed coating, make small seeds into big pellets so that they could be handled in planters. And then we are now deep in the spraying systems. And the patents are systems for the control and use of fluids and particles. It's good to have a good patent lawyer too. I want to patent a seeder, or I want to patent a sprayer, and he said, no, you want to patent systems for the control and use of fluids and particles. And we've done things all the way from making nanoparticles to and nanofibers to doing corn seeds. So this is an example of a field unit we're working with on spraying. That would be spraying fluid at 2 gallons per acre. And we've done lots and lots of testing, and the efficacy is really good. We've worked with the University of Nebraska at North Platte Station, and they've done trials with glyphosate as an example, all the way from a quart, a half gallon, a gallon, and 2 gallons, and then the standard things, and there's no difference in efficacy. So we're kind of excited about this project. Well, and traumatized too, because how do you go to the market? And we're a little company, and it's a big market. And so we're looking at it as doing a retrofit on the big sprayers that are out there. Now this is an example of the spraying technology. You see here we have a spray fixture set up. See, there's a little tube right here, and we're after the air cleaner and just before the turbo. And this is what that looks like with a spray fixture that has a 360 degree. And of course, you know the airspeed that's coming through there is really high. And we're able to make the drops fine enough so that they don't damage the turbo. And that engine with the tractor test laboratory testing is burning 80% ethanol and anhydrous, and both hydrous and anhydrous ethanol at the same efficiencies as they're getting out of the diesel fuel. You know, about a 40% efficiency. And what's happening because of the cooling that takes place with that is the NOx emissions are dropped about 50%. And so who's the entrepreneur out here that wants to take that project over? You know. So to wrap it up, systems to control use of fluids and particles, the fluid seeder, the crop sprayer. We're doing bulk seed treatment. You got all these things about atomization that are fuel, spray drying, particulate coatings. You know, you can spray particles. So what's the application in food processing? One of you food science guys. It's kind of like an octopus. It's got all kinds of tentacles hanging out there. Well, now things that I think I've learned, well, not near enough, but there are things that pop up that you got to think about. Is the product really important when you're looking? You're out there talking about some things today, and you guys are thinking about them, and girls, and don't get your wants versus needs mixed up. I've been there, and that's not good. What are your regulatory barriers? What are the resources you need on physical resources, you know, capital, people, and do you have time course restraints in getting to a market and to get a product? What are your competition/partner prospects? The NIH, the not invented here part of the world is real, and you walk into a big company, unless you have a track record, and you say, I've got this brainstorm and I want to have you sign a confidentiality agreement and show you the best thing since sliced bread, they're going to probably politely 99% of the time show you the door, because there are two things involved. One, they have big staffs that are working on things, and the people that you're dealing with don't know that they're not working on the same thing. And they don't want to compromise themselves with having the potential lawsuit. The other thing is, if it does go to a next stage, to be evaluated by the people that are doing the product development, that group generally does not want to say that there's something coming from the outside that we didn't do. And so both of those are very powerful factors. And so you have to develop some kind of a relationship with those big people before they'll talk to you. And I guess the other thing is that is, if you got a market definition, you got to have that. And then intellectual property. Is it an opportunity or a problem? We'll talk a little bit about the types of intellectual property next. And so intellectual property, you look at the things, you got patents, you got copyrights, you got trademarks, you got confidential disclosure agreements, which we just talked a little about. Then you have material transfer agreements, which they embody the confidential disclosure, and but they usually be framed in terms of working agreement. And so if you can get that kind going, that's pretty good for you. And then you operate on trade secrets, and that's not necessarily a bad way to operate. The patents that we have on solid matrix seed priming have expired some time ago. When they expired, our customers, the big guys like Syngenta and Bayer and Monsanto, they all went out and established facilities. But you don't always have everything in a patent. And so they're now some of our best customers. Even though they spent a lot of money setting up facilities, their customers still want what we do because it works better. And so trade secret operations can work. The other thing you need to think about, and we talked about this with some of you folks this afternoon, can you license technology if it's, or is there technology out there that you've got something that is a little off of it, but you might be able to license from someone else to give you a stake in the ground, a little barbed wire strung around what you've got. So you can look at it both ways. I have something to license, or I want to license something. Distribution factors, agreements can be big in the systems, as you well know. You guys take coursework on it. I just had to get beat on the head on it. But manufacturing, what we've had to do in manufacturing in our seed priming is we've had to make everything because you couldn't buy what we use in the processing. And so basically all of the things we do in our seed processing have been made in-house. So you have to decide. So franchising, that's obviously appropriate for many of the, possibly some of the things you folks are talking about. And so, no matter what, agreements are critical. So, well, learnings. Dialogue is really important in problem solving. Most of us, when we start thinking about a problem, can get in a rut. Matter of fact, I've never met anyone that couldn't. And so get a dialogue going. I mean, it's important because you're gonna, you wanna look at your hands like this, what does that look like? Wrinkles and stuff, and oh boy, that's the same thing, but that looks different, doesn't it? So you got get different viewpoints, a really important thing to recognize, learning. It's different than information gathering. And, oh yeah, Pat, you didn't look at that. All right, that's misspelled. So maybe she did, and I just screwed it up afterwards. But anyway, you know, think about it. Learning. That is really different than just gathering information, isn't it? And one of the ways you learn is going back to that first bullet. You know, get a dialogue going, get input, and this is so critical in product development or market development. Don't be afraid to not know. What you have to be afraid of is not asking. You know, if you're where you don't ask, well, it's bad. And so thinking about partnering, part of something better than all or nothing. So think about it as you try and go into something, you know. The other thing is be broaden your interest, acquire tools to think with, and you know, you're doing classes, aren't you? And so you're accumulating some tools up there. Some of you do something on your own to gain knowledge. And then there's experience. And those are the three things that I see that are primary, put tools up there to think with. And so focus on it, be aggressive at it, because if you're going to be off on your own trying to do a new business, you can only think with the tools that are up there, right? So just remember that. Nothing is new. What's new is when you put things together. So don't try and harness yourself with saying something, I've got to do something new, unless you're looking at it from putting things together. Because you're not going to make it if you say, I'm going to do something new. That's not a combination of things. Whoops. I didn't mean to say ethics is not critical there. This is really important in building solid relationships, and you just got to make sure that you're analyzing those that you're working with, as well as being the one that's setting the example on being ethical, because you're not going to have solid relationships unless you do. And you know, I guess, you know, one I didn't put up there that I preach to the guys at work. Have you ever heard that grandma says, Chris? Yeah, I've heard it. My grandma, she was from Germany, and she, when I was little, she'd say, Yanni, you got too smart, too little, too late, but Yanni, get smart. So that's really, do it a little bit at a time, but get smart. And so, questions?
I think I'll start off with a question. Pat, you've been pretty inspirational in John's life and working with him and raising a family, besides doing all this tonight. What was kind of your guys' trade secret, to a certain extent, about how you guys have made it work for so well?
Sometimes he's horrible to work with. solid relationships. And look here, my family's here tonight, and couldn't I? What could I complain about? You know, nothing.
For better or for worse, that's the key.
You guys have a question, just let us know. We'll get you guys the mic here.
So John, when we first met, one of the things you shared with me was there were some times when it looked like the company might not survive all the challenges. You might, if you'd be willing to share a little bit of those stories and perhaps provide the inspiration, because almost everybody in this room that's going to try something, there's going to come that moment where you think, this just isn't going to work, or everything's against me, and that notion of how you persevered, I think, is just it's a wonderful story, and it would be meaningful to this group if you'd be willing to share it.
Well, probably the deepest, darkest time was we were, after the solid matrix seed priming technology was going, we had a contract with Chemlon, and we were doing a little over 1 million pounds of bluegrass seed a year for them. And it was a nice thing. It kicked us off. We bought a building and hired a bunch of people to process the seeds and build a lot of equipment. And we were probably 2-3 years in it. And Ecolabs bought Chemlon. And Chemlon, we had an agreement with Chemlon that they purchased the rights in the patents to, they didn't license, they purchased the rights for turf seed priming. And Ecolab came in and said, nah, we don't want to depend on service providers and don't want to do that anymore. And so they sold those rights to a company of Utah called Genesis Seeds. And Genesis Seeds functioned for about a year and went bankrupt. And so we no longer had a customer. And we had a legal issue of what you could do trying to do other things, because now we had to get the rights and the patents back. And even though you default and I'll say, you know, legal systems are legal systems. And so we had to sell the building. We had to lay everyone off. Pat and I worked at a place without salaries. And we had one guy that we kept on. And I paid him by taking the money out of my IRA, my self-directed IRA, and shortly after that, the people that directed the IRA, the self-directed IRA, told me that was illegal, and I said, sorry, it's spent. So that was pretty deep, dark stuff, and we had done a lot of work on vegetable seed priming, and you know, you just only so much you can do in trying to go develop the market, but then you didn't have a choice. You get in the car and you start to California and you start pounding on doors, and you got germination dishes and leaving them on their desk, and you're doing hard sells and sleeping in the car at night. And so not all been rosy. And but we survived. We got the business, and it's growing. And now we've built new facilities in Waverly, and it's been good. And now we got sugar plum fairies dancing in our head now. And, we got Chris running the place, and so I'm worried about him. I told him the other day I was worried, and he looked at me, and well, what do you mean? I said, well, you're to the place reacting as bad as I ever did. And so that's You're gonna have to work on him, Jamie.
Mr. Eastin, I was wondering, I'm straight ahead. I was wondering, a lot of times when you talk about entrepreneurship, you talk about having a passion for what you do. How important has that been in your career life?
Well, yeah, I guess you get all that training and you think you know all the stuff, and the training and it was really important in being able to do what we did, and the passion to do new things was. That's why I left DeKalb. Pat told me I thought I had things that they didn't want to do that should be done, and, but yeah, you have to have a passion for it. You couldn't take it, you know. I guess. I think that's probably part of it. Yeah.
Dr. Eastin, I was curious about your business-to-business relationships and the importance of agreements. And I wonder if you could talk a little bit about your philosophy about how you enter into those, how you negotiate those. Do you go in with a lawyer next to you? When do you get legal advice, legal counsel involved? And just what's your approach to hammering out those kind of agreements?
Well, originally it was you had a lawyer. And then you learn the basics of agreements, and you learn that lawyers are like accountants and bankers and business plan writers. They don't know much about your business, and they can waste a lot of your money and a lot of your time if they're not deep into it. And so we were very fortunate that we had a lawyer who I couldn't pay, so he had to become a stockholder. And we lost him about 3 years ago. He passed away. He was an older codger than I am, and so we have, Chris and I both work on agreements, and we have a lot of agreements, several in place now that are programs in progress that we'll have a lawyer look at them if we need to, but we primarily do them ourselves anymore. And so it's a matter of experience, and after you've paid them enough for so long, why, you know, there are forms, and you got to fill in. You're going to have to fill in the blanks anyway. So, and wouldn't you say that's an accurate representation, Chris? I used to have to do them all, now I don't. Sometimes I don't think he even checks with me.
You might want to touch on a little bit about how you pick your partners and how you kind of control employee turnover a little bit. I think people might find that interesting.
Well, it has to be mutually beneficial. If it's not going to be mutually beneficial, don't mess with it. And partners develop because of results, and so they come out of material transfer agreements primarily, where you're dealing with projects, and and you have you do services for a company, and then they come and they say, well, we'd like to do some of that in-house, and so we're working with one right now where a very large customer, because of timelines, they want to do our processing systems in-house, and a lot of trade secrets involved, and we're a little nervous about it, but they say, well, money's not the problem, throughput is, and so they propose, well, they just pay us the same price we'd charge them, and they do all the processing. So that's pretty good royalty. So, yes.
When your company was in dire straits because your consumer was bought out by Eco Lab, what would you say your first initial reaction was, and how did you overcome it?
What do you say? What do you call it? Oh, shish. No, we just, you know, you have potential there, and so you buckle down, and you know, the banker's on your case because you got a mortgage, and bankers are good if you don't need them, you know, and they're not good if you do need them, and they're bankers, and so you know, and most lawyers are that way. And accountants are definitely that way.
What would you say your greatest motivation was during that period?
We knew we had stuff that was good. We had patents, and we had to survive. And so you don't even think about quitting. At least I didn't. I had a small car and germination dishes and some seeds, and you went out and you put them on their desk and said, this one's primed and this one's not, and leave them there for 7 days, guy. And so you, that was my sales tool, go and let him sell himself. But you put him right on his desk where he could not look at them. He didn't have to go to the lab to look at them. And so you saw those peppers, that's what he'd see. And oh. And so we, there were 2 species that were primed before we entered the scene, because they were doing it with solutions, and they're not friendly. And we've been through over 50 now. And I don't know how many we have in the price packet, Chris. I bet
It's got to be close to that.
and it'd be close to 50 in our standard price packet. And we get just routinely get calls from people saying, "Oh, what can you do with this?" And one of the things we learned, which has been it's a takeoff of the priming, is that if we you hydrate a seed, you know, it swells up, and you run it through the good metabolism, you get a lot of RNA, DNA, protein synthesis, and so some poor seeds will repair. And so you get a certain percentage of poor seeds in the seed lot that will repair and become good seeds. And then you get you know, seeds that will gravity separate. The poor ones will separate out because they're less dense. And we learned, had an idea that it might work, that okay, when I hydrate these seeds, and the good ones with a reasonable embryo in them are going to hydrate differently, swell differently, and the free spaces in the seed will change. And sure enough, that works. So we can take seed lots that they can't sell, and we can run them through the priming, and then gravity separate them because of the priming, whereas they couldn't do that before. So we get a number of seed recovery, like seed lot recovery things every year. Yes, sir.
If you could do everything over again, knowing everything you do now, what would you do different?
I don't think I'd be smart enough to do different. Yeah. I mean, you just have to react. We're a little more careful now about, we don't take on as much. Experience is a good teacher, but in principle, you got to move forward. You're doing something new, and there's risk. And you don't know until you're in the marketplace, and you don't know. See, you never know what the reaction is going to be from someone who could be a competitor. And all of a sudden you're doing something that hadn't been done, and you got some big company out there that's got all kinds of capability more muscle than you could ever dream of. Oh, well, we know how to get around that patent, and because you've taught them something. And so, but I don't know that you can forecast that kind of thing. I've never really thought about it. You think you'd do anything, Chris, different than what we do?
I haven't thought about it that much.
Well,
We got to the right place, right?
yep, we're, no, I don't know that I would have a different strategy. You have to look at, okay, what's the market, what's technology, what's the niche, and you start with the niche, which if you're doing something like we have to do, you're small, we're not trying to compete with the big guys. We don't try and take that on. Our mission is make their things better. And you do it by enhancing their product or delivering their product in a more efficacious way. Because they're not going to go away. You know, so.
I have a question. Coming from a small background, and we've toured a lot of businesses over the last years as an Engler program, and every one of the business owners said that culture was very important for their work environment and in order to retain employees. Can you explain what your culture is and how you developed it?
Well, we try and we have a program that we have excellent benefits. We have 90/10 insurance. We have profit sharing. Every employee, for every year they're there, they get the equivalent of 500 shares in the company, and they get profit sharing distribution the same way those who invested in the company do. And so we've had some people that have been there 20 years, and they get pretty healthy profit sharing when we make profit. They don't necessarily like the idea that we reinvest at least 25% of our revenues in R&D every year. So that's but no, they're pretty happy campers because of the benefits. How you develop a culture, it's a constant battle. And it's worse in today's workforce than it was 20, 30 years ago. The Twitter and Facebook and the way society communicates stupid things, I guess you'd say, it's pervasive, and there's nothing you can do about it. But we try and keep them informed as much as we can of everything, and we're a little bit complex in what goes on, and so there's always an unhappy camper, but we've made a lot of progress in the past few years, and but you really have to pay attention. You really have to focus on it.
I think we have time for one more question.
Okay, how does having family for business partners compare to other business partners that you could have?
Is
it good? Is it bad?
Yeah, I don't have a comparison except for her, and we were 24 hours a day. She came to rescue me and organize a business, and because I was the wild man, and it was pretty great. But we don't have family involved in the business. We've never even thought about it. Nobody said they would want to come and work for me. I don't know. I have to start working on Elizabeth. You're young enough; you might be influenced.
Well, Without forward-thinking individuals like yourself, John, we probably wouldn't be here tonight whatsoever advancing agriculture. Your tenacity, spark, and your work is really fighting global hunger overall. And your knack for problem solving is truly inspirational and giving us some tips on solving that as well.
Well, I really appreciated the chance to visit with the kids this morning. It was fun. You know, Chris let me off.
As we've seen today, your wife Pat has played an extremely large part in your life and your business. Together, you've brought your beautiful family here. Your daughter, your daughter Beth and her husband John, your other daughter Jenny and her husband Shannon, and their children Andrew and Elizabeth, and then also you have with you the president of your company, Chris, and his wife Jamie. So thank you for being here with us tonight.
My pleasure.
And John, as a symbol of the time that you have shared with us, we'd like to give you a medal with a portrait of Paul Engler, and who was our founder upon that. The pillars of grit, aspiration, courage, building, and passion in partnering are the foundations of an Engler entrepreneur, and is overwhelmingly evident in your life and business. If you feel the same as these traits I've just mentioned, and you're ready to take yourself to the next level, the Engler Entrepreneurship Program may be the right thing for you. So if you'd like to talk to Tom Field, our director, or Dave Lamb, one of the professors involved, if you want to start today for tomorrow, tonight might be the night to take that first step. So, Autumn?
Thank you again for joining us. We're going to have a little bit of networking time to talk, ask more questions maybe if you have the chance, and then there's refreshments in the back. So thank you again for coming out tonight.